Okay, chapter 5 now, quadratics. You did a lot of this in Algebra 2, so hopefully this will be familiar with you. Write the equation of a parabola in standard form. Find the coordinates of the points corresponding to P and Q. Okay. Find the coordinates of the points corresponding to P and Q. They already have P and Q listed there, so I don't understand that. Write the equation of the parabola. All right, so vertex form is that right there. A is your opening up or down and how wide or narrow it is. We know inside of the parentheses is the opposite of the x-coordinate of the vertex, and the k is the exact same as the y-coordinate. So this vertex right here, as we see, is -3, 4. Okay, so right here, this would be x plus 3. That makes it -3, and it's the same sign on the outside, +4. Now the only question is what the a is here. Okay, well, if it's going right 1 and down 1, that's just your normal parabola, your parent graph of x squared. So I plug in 1, okay, and then, well, negative, that is, opening down, okay? So if I have negative of x squared, so I plug in 1, I get -1. If I plug in -1, I also get -1. It puts it over here. I plug in 2, I get -4, and I plug in -2, I get -4. Okay, so that's right there. Now, let's say that's still difficult for you to figure out. Okay, I can go to my graphic calculator, do stat, edit. Okay, if I want to clear my list, go up to the top here, hit clear, enter. Go up to the top over here, hit clear, enter. Don't use delete, use clear. That's the fastest way to clear them out instead of having to delete each one. Okay, I plug in the points, -4 for the x-coordinate for that one, and -5 for that one. Okay, go over to the y-coordinates, it's 3 on that one, and it's 0 on that one. Okay, and I do stat again, move over to calc, and it's a quadratic. So I go down until I hit quadratic regression right there. Hit enter, and it says, did you put your x-coordinates in L1? Yes. I put my y-coordinates in L2? Yes. So I can just hit enter, enter, enter. Just go right on through there. Oops, domain. Okay, so the domain means my window is not good. I gotta change my window. Okay, so window, if I go to that, let's go zoom 6. Go back to your standard window. Okay, I can clear that out of there and that out of there. Okay. All right, so now go ahead. If that happens, just clear that out. Okay, go back to zoom and hit zoom 6 for your standard window. Now I do my stat again, over to calc, down to quadratic regression, because the quadratic is not linear, it's not a cubic. Hit enter, 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 all the way down. Dang it. Domain, where's my window here? Window. Okay, let's quit out of there then. Window, okay, that's good. So I wonder if it only if it needs 3 points. Okay, it needs 3 points is what it needs, that's why. So go back to stat, that's what happened there. I didn't put 3 points, it needs 3 points. Okay, so what do we know another point is right here? We had -5, 0, and we had 0, 0 right there. So plug that in. 0, comma, 0. Oops, I need to move it over before I put the other 0 in there. Get rid of that one. Delete. Over there, 0. Enter. All right, now it should be good. Now let's try it. Stat, calc, quadratic, regression, enter, 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 go through there, and there's my answer. This is not -5. It should not. I type in my numbers correctly. Stat, edit, -4, 3, -5, 0, and 0, 0. I see. See how I thought it was 0, 0? Because I know I have my answer right up here. So I have more confidence in myself in the calculator. That's why I'm going back and checking. Say there's something wrong with the calculator, something. See how I said that was 0, 0? It's not 0, 0. How many of you caught that? How many of you just blindly believe me? See, I use my brain. I said, no, I know I have the right answer, and that's not giving me the right answer. Here's the 0, 0 right there. So this is -1, 0. That's why. Okay, so it's -1, 0 over here. -1. Enter. All right, now stat. Boy, there's a learning lesson right there. Okay. That's why if you know what you're doing, you have more confidence in yourself than you do the calculator. And there you go right there. So what this does, this kicks out in standard form for you. Notice I have it in vertex form, so I'm not done yet. Okay, so let me write down the answer first. -1x squared minus 6x minus 5. Okay, now this is vertex form. Put it in standard form, I need to actually square out that right there. And I have negative of that. That's x squared plus 6x plus 9. Remember, you square quadratic. Square the first term, multiply the two middle ones together. That gives you 3x. Double that to 6x, and square your last term plus 9. And then I have my plus 4 right here. So notice now, this gives me negative x squared minus, not plus, minus 6x. And a minus 9 plus 4 is minus 5. The exact same answer as that right there. Okay, so there you learn some errors I just did along the way there. So if you come across them, you know what to look for. Go back and make sure you plot and put in the right point right there of that -1, 0 instead of just calling it 0, 0 as I did. Okay, so let me erase that now. Sketch the graph of the parabola. Okay, so I'm sketching that. 3, 4 is my vertex. 1, 2, 3, 1, 2, 3, 4, 3, 4, and I have 5, 8. 4, 5, 6, 7, 8. So 5, 8. Now, here's how I get my third point. Remember, I need 3 points to plug in. We just learned that because we only plugged in 2. You need 3. You have 1, 2 right now. Well, what I do, I went from 3 to 4. I went right 1 and up 4. So that's the same thing. I can go left 1 and up 4. So there's my 3 points now. Remember, this is called the axis of symmetry or line of symmetry. Splits it right down the middle through the vertex. Okay, so that equation is x equaled 3 if they wanted the axis of symmetry or line of symmetry. Yeah, here they're doing it right here. Identify the line of symmetry and the coordinates of the vertex. Okay, so I'm talking about that right now. Okay, so what are my points right there? Obviously, they gave me 2 of them. Right there, 2 points. And what's this third point? 2, 8. Okay, so if you want to write down here, 2, 8. Now, oh, you just had to sketch it. You didn't have to come up with the equation. Okay, so now I'm just sketching it. Comes down through here, comes back up like this right there. If I wanted the equation of that line in standard form, now I have my 3 points I could plug into my graphing calculator like I just did. Okay, so you saw how you do that. All right, graph the quadratic equation function, identify the axis of symmetry. That's the vertical line that goes right through the x coordinate of the vertex and the coordinates of the vertex. Okay, you can plug these into a graphing calculator if you want to get the, if you want to know, and you should have this memorized, x equals negative b over 2a. That is the x coordinate of the vertex. X coordinate of vertex. And then I take that number after I get it and plug it back into the equation and get the y coordinate. And then I have the vertex itself. This also is the axis of symmetry. X equals this number, whatever it is. That is my axis of symmetry. Okay. So again, this should be review, and hopefully you're remembering this here. Write a complex number. Remember, complex number is a plus bi with an absolute value between 3 and 8. Write a complex number with an absolute value between 3 and, oh, okay. You don't have to do this one. Absolute value, what that means is the distance from the origin. Absolute value, which is going to come down. It's explaining how to find the absolute value of any complex number. So you're having this question here. It means the distance from that point to the origin. So you end up using distance formula or Pythagorean theorem. And what they're saying, they want the answer to come out to be between 3 and 8. You come up with your own complex number. So our number between 3 and 8 is 5, right? So if I go, so this is my real number line, and this is my imaginary number line. So if I go 3 in the real direction and -4 in the y, which is the imaginary direction, that'd be 3 for the real, oops, minus 4i. This is my I-axis. So that's really, it says 3 comma -4 right there. Well, that distance, the absolute value, means the distance from 0 to that point. Well, that's 3 and that's 4, and we should know from our Pythagorean triples that's a 3, 4, 5 Pythagorean triples. So that distance is 5 for the absolute value of that. So the absolute, so if you saw this, absolute value of 3 minus 4i, that answer is 5. It means what's the distance from the point 3 minus 4i, which is right here, 3 minus 4i right there, to back to the origin. And there's your Pythagorean triple of 3, 4, 5. Okay, so I just did that one for you. Simplify these, you're just multiplying them together. Don't forget, when you come down and you have negatives underneath the absolute value, those are i's. So square root of 9, or -9, is really 3i. Remember that? If it's a negative, you pull it out with an I, and the square root of 9 is 3. Okay, if you're multiplying two i's together, when you get to that, remember I squared equals -1. Don't forget that. Additive inverse would just mean switch these signs. Okay, so it adds a 0. Okay, the absolute value of each complex number, that's what I just got done telling you, the distance from that point to 0. So where is 7i? 7i is just straight up on the 7 up here. 1, 2, 3, 4, 5, 6, 7. Right up there on the y-axis. How far is that from 0, 0? You don't need anything difficult with that. It's just 7. Very simple. How far is 12 out here from 0, 0? It's 12. Real easy. This is the only one you have to do any work on where you're plotting like this. So don't forget, that's -3 and -2. That point right there is -3 minus 2i. Okay, so you use Pythagorean theorem or distance formula. I prefer Pythagorean theorem. Okay, and figure out that distance. Leave it as a square root. Okay, it didn't tell you to round. All right, next page. All right, solve the quadratic. Okay, so you can do it by hand, by factoring the factors, or you can go ahead and put the graph in calculator. Okay, 23 should be easy. You have x squared equals 16 when you add that across. Remember, this tells me how many answers are. All quadratics have 2 answers. So when I take the square root, I get x equals plus or minus the square root of 16. So x equals plus or minus 4. Don't forget that. You're going to have 2 answers for each of these, whether real numbers or imaginary numbers. Okay, or complex numbers. Okay, you're going to have 2 answers. This right here, you could factor that if you wanted to. X minus 1, x minus 4. Okay, if you factor that, then you set each factor equal to 0. So then you get x equals 1, or x equals 4. 1 or 4, there's your 2 answers. Don't forget, if it doesn't come out nicely, so how do I know if it's going to factor? If b squared minus 4ac is a perfect square. Okay, If that's true, remember b squared minus 4ac, that's my standard form of a quadratic, is ax squared plus bx plus c. So there's my a, b, and c. So if I do b squared minus 4ac from there, if that number comes out to be a perfect square, then it will factor. So let's just test one of these right here. Number 24, b squared is 9 minus 4ac. So obviously negative times negative is positive, so I have 9 plus 88. 8 times 11 is 88. What's 88 plus 9? 97. Is that a perfect square? No, it's not. So that means this will not factor. So instead of using quadratic formula, go ahead and just use your graphing calculator. So how do I play in the graphing calculator? The quickest way to do it, to get your answer. We'll do it one time, pay attention. Okay, y equals, I type the first one in, 2x squared. Let me move this up here. 2x squared. Back. Delete. Delete. Squared. Ah, dang it. Delete. Come back here. All right, clear this whole thing. It's ridiculous. 2. Let's try that then. There we go. Once you put the 2 in. 2x squared. What is it here? Minus 3x minus 11. Minus 3x minus 11. Okay, enter. And the second equation, put in y equals 0. Okay, this is the quickest way. You're going to use intersection. So I'm going to do second calc intersect. Number 5. I'm going to find where that curve crosses the x-axis. That's what I'm trying to find. Remember, these are my solutions, also called roots, x-intercepts, and zeros. And the calculator is called 0. Okay, there's the 4 names: solutions, x-intercepts, roots, or zeros. Okay, all you do is hit first curve, second curve, and the first time I can just hit guess right away. It's going to jump to the closest one. So I get negative 1.7. We're going to just go ahead and round to the nearest tenth. So negative 1.7, or to get my second one, that's the negative 1.71. To get the other one, I do second calc, number 5 again. First curve enter, second curve enter. This time I use the right arrow and move it over toward the other answer. As long as it's more than halfway, it's closer to that answer than the other, it will jump to it. And you see 3.2, approximately 3.2. Okay, now I could technically do that for every problem here, but you might want to practice your factoring. If it factors, if you just can't figure out how to do it, then just go ahead and plug in the graphing calculator. Okay, solve by completing the square. Okay, I'm not going to have you do that. We're going to have you just go ahead and plug these in the calculator. Okay, that's going to take too long to go through. Plug into calculator, just like I just showed you. Get your 2 answers. Remember, they're all going to have 2 answers. Write each function in vertex form, sketch the graph. Okay. So in here, I will go ahead and show you. All right, I'm going to show you the shortcuts. Okay, again, if it was in person, I'd have more time to go through and explain it. If you know how to do it by completing the square and put it in vertex form, that's great. So write each function in vertex form. That's the y equals a times x minus h quantity squared plus k. Okay, here's a shortcut. Let's call it cheating, so because you're not having to show any work. All right, so here's how it is. A is whatever this A is right here. That doesn't change. So in this case, A is 1. In this one, A is 3. In this one, A is negative 1. This one is A is 1/2. Done deal. We're just doing 33 right now. So I already know it's 1. H and K are my vertex. That's the vertex of the parabola. Okay? So it's x something squared and then plus or minus whatever the K is. So how do I get the vertex? Remember? I told you. I could first off just play in the graphing calculator and get the vertex from there, but at least do a little bit by hand. Negative b over 2a, I just showed you this. That's going to give me my x coordinate. So in this case, negative b is negative 4 over 2a is 2. So the x coordinate is negative 2. So I know I go the opposite here. So it's going to be plus 2. Plug negative 2 into that equation. Negative 2 squared is 4. And 4 times negative 2 is negative 8. And then minus 7. So 4 minus 8 is negative 4. Minus 7 is negative 11. Y is negative 11. So then there's my k right there. That's a quote quick cheating method right there. Or you can just put in a graphing calculator and get the vertex and plug in the h and k right there. Okay. And so go ahead and do that for the other ones there. All right, evaluate the discriminant of each question. Remember, the discriminant is that b squared minus 4ac that I just showed you to figure out. Remember, if I do b squared minus 4ac and it comes out to be a perfect square, then it will factor. That was called the discriminant. Okay, so it says evaluate the discriminants. They want you to do the b squared minus 4ac here and determine how many real and imaginary solutions. So here's the rule. If it's greater than 0, 2 real. If it's equal to 0, 1 real. And if it's less than 0, it's 2 imaginary. Okay, imaginaries always come in pairs. Same with complex answers, always come in pairs. They're never by themselves. If you remember that as well. Okay, so that's what you're doing there. 41, Anthony has 10 foot of framing and wants to use it to make a large rectangular picture frame possible. Find the maximum area that can be enclosed. The ball is starting upward. Find the maximum height. So you could just sit there and type that in the graphing calculator. Maximum height always occurs at the vertex. You see this negative t, 16t squared, it tells you it's opening down. The maximum height always occurs at this vertex. Okay, so you can get the vertex off the graphing calculator or do what we just did right up here. Negative b over 2a, get that x coordinate, plug it back in, get the y coordinate, and there is your coordinates of the maximum height, but it wants the maximum height. The maximum height is only the y coordinate. Okay, so it's not the x coordinate, it's only the y coordinate, and of course it tells you what the units are, feet. So whatever that ends up being, you put feet for your units there. Suppose a parabola has a vertex in quadrant 4, and a is less than 0. That means it opens down, quadrant 4. So you have something like this as an example. How many real solutions will the equation have? What that means, real, remember this is the real number line, and this is the imaginary one. So does it cross the real axis or the x-axis at all? No, so it has 0 real solutions. Okay, so there you go with that. All right, we're done, 23 minutes.